So, hello, my name is Rikke Hagensby Jensen, and I'm currently a postdoc in the Human-Centered Computing Group at Aalborg University. And as part of my PhD project, I wrote this SIGCHI paper, which I'll be presenting today. I wrote the paper along with my two PhD supervisors, and they're here somewhere. We named the paper Assisted Shifting of Electricity Use, a long-term study of managing residential heating. And it's a user study that describes a study we conducted as part of a larger research project running from 2014 to 16, investigating the development of technical, sustainable energy solutions for private households. So in the study, we really wanted to understand how private householders experience sustainable smart energy systems. And therefore, our study is situated in the home, focusing on designing interaction with such systems, understanding how they become part of everyday life and the energy impacts they may have. And based on this onset, our contribution is threefold. Firstly, we really wanted to create an interaction design where people can express and control their heating using renewable energy. And we named this HeatDAO. And the main reason for wanting to create such a design was to obtain insights into how people experience the smart energy over a longer time or period in real-life conditions. And lastly, we wanted to expose and discuss the opportunities and challenges of designing for intelligent, sustainable energy systems. So before I really dwell into these contributions and how they came about, I would like to shortly set the context of our study. So in Denmark, there's been some ambitious initiatives aiming to transition our energy productions towards being 50% renewable by 2020, and we're close. This transition has mostly involved investing in wind power, as we have quite a lot of wind in Denmark. But wind power is only available when the wind blows, making this form of renewable energy a rather inflexible energy source, as it might not be around when people want to use it. So to overcome this, people are expected to sometimes use wind power only when it's available. And one vision to address this is to build technology that assists people to shift their consumption to be aligned with wind power. So in the paper, we have an extensive related work section on designing interactions with smart sustainable energy systems. And in the paper, we categorize them into eco-monitors and eco-managers. And these are 4 examples. You can find a lot more in the paper. And a lot of this work inspired our study. However, back in 2014, when we started to plan our study, we read Silverman and colleagues' interaction paper discussing the next steps for sustainable HCI. And in particular, 2 of these suggested steps influenced how we approached our study. So 1, it offers suggestions to do research that consider longer timescales. And 2, to build and support systems people use in their everyday practices, and do studies that inform the design and operations of such systems. So, in our study, we decided that heating with heat pumps should be the focus. And why? It's because one scenario where Danish people are expected to shift their consumption is when heating houses through electrical heat pumps. And although heat pumps consume a lot of electricity, they're also seen as a green alternative to heating if they use renewable electricity. And because heat pumps can be controlled from the outside by external actors, they can also be smartly controlled when they should run, and thereby assist households to shift consumption to times when it's sustainable favorable. So on this onset, we set out to build a prototype that was able to assist people to shift heating, and the end result was the HeatDAO prototype. The prototype consists of 3 parts. It has an interactive web app where households can define the shifting behavior of the system through 2 settings. They do so by setting a preferred temperature, and it's 21 in this example. And also they do it by setting a comfort zone. And this is a range where the temperature is allowed to fluctuate within, which the user sets. And this example is set from 17 to 25. And it was really designed with the rationale that the larger the zone, the bigger potential for shifting consumption around. Users are also shown the current temperature. Here it's 23.6. And we also provided some forecasting information showing the benefits and consequences of choosing a specific setting. Here it illustrates the potential savings and temperature fluctuations within the next 24 hours. The second part of the system is a centralized intelligent scheduling system that automates when the heat pump should run. And it was controlled by a local startup company working on smart grid solutions called NeoGrid. And the third part is households with the heat pumps and sensors that could be controlled from the outside. And there's a lot more about the system design in our Nordic Kite paper from 2016. So to really help us understand how people experience living such a design in real life, we conducted a long-term field study with 8 households. 4 participated for 18 months and 4 participated for 6 months. And we collected both quantitative data in form of logged interaction data, heat pumps performance records, measured temperatures, and qualitative data in form of 20 semi-structured interviews, and we also did some technology tours. So, first, I'll present some of our findings from our quantitative data set. So, from our logged data, we can see all the households kept using the system during the time they participated in the study. And from this data, we can also see that all the participants chose comfort zones that was wide enough to enable system or shifting in the system. And they are represented by the pink graphs here. This meant that the heat dial system became part of the heating practices, also enabling electricity savings illustrated by the green graph. But we could also see from these numbers there's no direct correlation between the size of the chosen comfort zone and the electricity savings, and there's different reasons for this. So how the participants actually experience living with the heat dial system is represented in 3 overall themes that summarized as convenience, control, and complexity. And there are different aspects to all these 3 themes. In this presentation, I'll focus on 5 of them. There's a lot more in-depth description of all of them in the paper. It's a long paper. So, the first theme of convenience represents how participants experienced the heat dial system as a convenient way of consuming renewable energy for heating. And one reason for this was because the household experienced the system as being non-intrusive. Because the way we designed the system as we did, it did not really require these households to change behavior, or nor did it disrupt how they normally heated. The heat dial system just faded into the background of everyday life. The wife from household C, for example, thought of the system as something that had never existed. It just ran. And this non-intrusive behavior was one of the main reasons why assisted shifting became part of these people's heating practices. Another reason why they experienced the heat dial system as convenience was because all householders thought that shifting heating consumption around was a really mundane task they were more than happy to automate. And this had something to do with the nature of how heating was already practiced in these homes. They already expected that heating activities were something that was semi-automated by technology like the heat pump. So the husband in household D, for example, thought that heating was different than other activities. He preferred automating the running times for the heat pump, but heat is not like other activities. It should just take care of itself. The next themes relate to how householders experience a sense of control of how the system would assist them to shift, especially due to them being able to set and control the boundaries of their comfort. And this really influenced how they seemed to accept that the heat dial system would make choices on their behalf. because they still felt that they were in control of their comfort. But we also saw that many of the householders started to check up on the system, creating these new routines around heating. Some participants started to log their own data, checking data on various apps. This was reflected by the wife in household E. She noticed that her husband started to use time almost every day, just checking the system behave as he expected it to do. And it's kind of interesting because it contrasts the previous theme of convenience. So the householders who engaged in these new routines saw no sort of inconvenience in spending time, and some of them spend a lot of time to go locate, collect, and interpreting these numbers. We also saw when they did not feel in control of the system, some of them became quite creative in ways to try and fool the system. So the husband in household E started to trick the system into thinking that it was colder than it was to make it heat faster. So he did so by putting one of the sensors in the fridge till he felt that the living room was warm enough. And that was not the intended system behavior. So the last theme describes how the complexity of designing such systems for real-life conditions. So we discovered that after living with the system for over a long time, the participants starting to refer to the indoor climate as a comfort zone, and it was really based on our design convention. The husband in household G, for example, described heating as a comfort zone to regulate heating with. But we also discovered that designing heating with temperatures represented as Celsius degrees do not always represent how people want to heat. They might want different temperatures in different rooms, or through different seasons, or during different activities. And because the heat dial system did not really accommodate for such complexity, we did observe some unsustainable practicing occurring, like heating with a heat burner, like here, or if it got too cold, or sometimes they'll open the windows if they got too hot. And it shows that we as designers can have quite a decisive hand in how such systems are understood, and the expectations such designs carries with them. So in our paper, we have 4 discussion points reflecting on us carrying out the study, and I'll touch upon 2 of them in this talk. So as we carried out our study for a long period of time, we believe we were able to get more in-depth data on how and why people adapt to smart energy interventions that goes beyond the initial excitement period of just getting new technology into the home. And as we get richer insights, we're also able to say something more about how such technologies become embedded in practices, the expectations they might carry with them, and the real energy impacts they may have. And therefore, we believe that long-term studies are well suited to uncover potentials, but also mismatches between a designer's assumptions, intentions, and the impact such designs can have on everyday life. We also see from our log data that assisted shifting with hardly any trouble became part of these participants' heating practices. And the core reason for this was because it just nicely faded into the background of everyday life. However, this way of designing smart energy technology also, to some extent, moves the responsibility to act sustainable to an external actor. So what our study also shows is that fully automated systems like the heat dial system do not always assist households in changing attitudes or challenge behaviors, because sustainable issues also fade into the background. So we believe these observations relate to a tension between one hand the vision of home computing, which is really represented in the heat dial system, and the other hand on Roger's vision of creating more proactive, engaging experiences through computing that are really more designed to make people reflect and challenge their practices. And because we as designers have this decisive hand in the kind of expectations a design carries with it, we really want to highlight the importance of finding a balance between these visions in the design and development of sustainable smart energy systems in effort to better them as sustainable co-managers of everyday practices. And that really concludes my talk. But before I finish, I would like to thank the GoFlex project for sponsoring my Kai trip. And me and the authors, my two other authors, would like to send our gratitude to the external reviewers for their really constructive feedback in the reviewing process. And Papa Christmas, he's not here today, but he helped with the data, the quantitative data, and actually also Jenny Pei, she's here, and Yulan Stringers, they helped us review the final version of the paper. Thank you.
Thank you very much. Questions for Rikke? Yeah, please.
Hi. Thank you for a really, really nice talk, and I'm really looking forward to delving into the depths of that paper. My name is Simone Stumpf. I'm from City University of London, and I think what is also coming out, especially in your discussion, that you're exposing some part of what is essentially a black box system. And there's many misconceptions around smart heating and how heat pumps work. For example, in the UK, not many people have heat pumps, so they're used to gas boilers, and I recognise some of the workarounds that people have there. My question is really about how do you see the way forward to addressing some of the challenges around these black box systems that smart heating systems actually are?
Yeah, so I really think that we need studies, first of all. So a lot of technology is being built. I'm in a computer science department, and they build a lot of technology, but they forget to actually deploy it out in the field and see how people actually incorporate it in their practices. So we need to be a bit more critical, but also think there's opportunities in it. And I think we as HCI researchers or interaction design researchers, we have a big responsibility to actually challenge some of these assumptions that's in the system or in this vision. So, yeah. And we can do that by different means. We have also worked with other ways of trying to trigger how people expect these systems to work in my PhD. So, yeah.
I have a question and then a short story. First question is, did you consider water? Because water has such a high thermal capacity.
And it's not really, in my talk, it's not touched upon, but these heat pumps actually also produce utility water.
Sure.
And it was a problem sometimes because they needed water for showering. We had a family who had 4 little sons, so they actually had to stop the system, I think, every Sunday morning. The wife did. So yeah, so it was definitely part, and it's not really captured in the heat dial interface and how they could set it. So yeah.
Now I'm going to give you a short story, and there's going to be a question.
Yeah.
I started a company in 2009 that focused on this.
Yeah.
We won the 2011 Global Clean Tech Open. We couldn't raise $6 million, so now I work for Microsoft. Okay, so Microsoft was one of my customers. And the reason we couldn't raise money is because in North America, there's no price signal for renewable energy. We coined a phrase called Renewable Demand Response, RDR, and the BPA, where I live in Seattle, funded a study of 100 homes. It worked well. But my question is there a price signal in Denmark for shifting energy to use more renewable resources?
Yes, it's in the process, but
awesome.
But I also think in the paper we actually, it's not here, but what we observed was that they didn't really care that much about the price. It was the comfort, you know.
Oh,
so
I agree. But if you got to get money for a company, they care about the price.
Yes. Yeah.
Yeah. Hello. My name is Gunnar Stevens. So thank you for the long-term orientation. I think we need more of these studies. And we also make a long-term appropriation study of the smart home, and therefore see many of these patterns you mentioned. And I also, in our case, we see some temporal patterns. So in the beginning, we have a lot of control and monitoring, and later on, it become more a background service. So did you also observe some temporal process in appropriating your system?
I think not really. I think in the paper they had a tendency to, after a while, to make the comfort zones smaller, actually. But I think the most important thing was actually the season of the, so when it was winter or spring, they used the system more. In the summer, they didn't use the system at all. So other things influenced. But they didn't interact with the system that much because it just, it just operated by itself. Yeah. Yes.
Thank you very much. Thank you, Rikke. Thank you.